All right. Hello, everybody, and welcome to our WPF Code Clinic. I'm Greg Lutz. I'm a product manager for the ComponentOne product line for Meshes, and I'm a longtime WPF user and even a guru, if you will. Last month at the Microsoft Build event of 2024, it was made clear that WPF and WinUI are the desktop platforms to invest in, at least within .NET Windows for your new applications. So now is a great time to be looking at WPF as a possible development solution for your upcoming Windows application projects. In this Code Clinic, we'll look at how WPF compares to Windows Forms and WinUI 3, which are the other two viable solutions for Windows development. I'll share some of the types of applications that you typically build with each, and then we'll demonstrate how to get started building a WPF application. And while doing so, we'll cover some best practices for building those user interfaces, and ultimately help you determine why you should choose WPF for your next native Windows application. But before we begin, let me cover some basics. So as you probably know, WPF stands for the Windows Presentation Foundation. It's part of the .NET framework, and it includes everything related to the UI. So this includes the application model, the resources, the controls, graphics, the layout components, the data binding, and so on. WPF heavily uses this thing called the Extensible Application Markup Language, commonly referred to as XAML, XAML. Now, this is to provide the declarative model for the UI, and as well as the application programming. And aside from that, development for WPF is very similar to Windows Forms or ASP.NET, or pretty much any other .NET framework that you may have developed with. You use Visual Studio to write the applications, and the code can be written in either C# or VB.NET. So prior to WPF, there was, and there still is, Windows Forms, also known as WinForms for a little bit shorter. WPF never fully replaced Windows Forms, since both frameworks rely on the Win32 libraries, and Microsoft has continued to support Windows Forms application development all of these years while WPF has been out there as well. Both are still viable solutions for developing Windows desktop applications today. But WPF can be seen as a newer technology by comparison. So let me go through some of these benefits that WPF has over WinForms. The first and the biggest one, or one of the biggest ones, is its adaptiveness and responsiveness. So WPF uses XAML, which is a lot like HTML in that it's designed to scale with the client's window. Therefore, the apps that you produce are a lot more responsive or adaptive than the WinForms apps out of the box. WinForms has this anchoring concept where you can anchor elements to the edges of the application, but WPF has a lot more flexibility in creating these richer UIs that are scalable. And as a result, sometimes WinForms apps can look bad on these new high-resolution monitors. Second big thing is styling. So WPF has this style concept that allows you to encapsulate all the settings for the UI and reuse them seamlessly throughout your application. Not only that, but WPF controls are just inherently more customizable than WinForms, allowing you to create very custom designs more quickly and more easily. And another big one is data binding. WPF has been designed so that you can practically data bind anything to anything. So you can literally bind one control property to another controls property without writing any code. All of this can be done through XAML. And data binding to collections and data objects with rich UI templates is also just part of that bread and butter of WPF. And I'll demonstrate some of that in a bit. Another one here is MVVM, like MVVM friendly. I would say WPF is undoubtedly more MVVM friendly than WinForms. You may have heard about it. It's the model view model pattern, and it's a popular design architecture that really builds upon the data binding capabilities of WPF by allowing you to very easily separate the UI from all of the code and logic. And it doesn't mean that you can't do MVVM and WinForms, but just that WPF has been designed for this architecture. And WPF uses DirectX under the hood, so naturally it's going to be better performing than WinForms. So by comparison, WinForms uses GDI, which is an older graphics drawing technology. And the problem is that GDI pulls directly from the processor and puts a burden on that processor and can really slow things down in your application. And the GDI technology also predates a lot of the modern video cards. So since WPF can talk directly to the video card, this generally results in a higher performance for your applications. And finally, this big benefit is the scalability. I would say WPF is more scalable. And what I mean by this is that you can, by separating the UI from the business logic following WPF best practices, it's more scalable to other .NET technologies. Like let's say you're also building a web component with MVC or Blazor, or you want to move to .NET MAUI for mobile. If you've separated your code with the XAML and the C#, you can more easily scale to other frameworks. So, and overall, WPF utilizes that full operating system like WinForms, but it's designed using these more modern .NET best practices like XAML and MVVM. Because if you consider, since WPF has come out, basically every other new non-web framework that Microsoft has put out with .NET has followed WPF in terms of using XAML and its basic application structure. So if you remember a lot of these things like Silverlight and Windows Phone, WinRT, UWP, and Xamarin, and even the newest ones like .NET MAUI and WinUI, they all use XAML. They all are very similar to WPF. So this tells me that XAML is a technology that's here to stay and will likely be used for the next technologies created in the future for .NET. But there is one other option that you should consider for your Windows desktop development, and that is WinUI. So WinUI is the other modern choice for desktop development and a great one for certain use cases. So understanding WinUI, I think, comes down to really understanding the history of what Microsoft was trying to accomplish with modern computers and tablets. I think it all started about 12 years ago when Microsoft switched a lot of things up when they moved to from Windows 7 to Windows 8. There was this ARM architecture for tablet devices they had, and they basically tried to reinvent a lighter version of Windows that could run on tablets, and they called that WinRT, Windows Runtime. This is at least how I saw it. And with that came the need to build new, lighter apps for these Windows tablets. And these apps were called Windows Store apps, also known as Metro apps. And Metro was the design term being used. Now, these apps didn't nearly have as much power or flexibility as full Windows desktop apps that you built with WinForms or WPF, but they did use XAML, and they shared all those same design, the style, the data binding, capabilities as WPF. Then Microsoft continued to evolve and shift the development ecosystem with Windows 10 and Windows 11, but they kept that lighter application model for developing these modern, tablet-first applications for Windows 10 and 11. They now call it WinUI, and it's also referred to as the Windows App SDK. Specifically, we had WinUI version 2, and that was with Windows 10, and that one was actually at the time more commonly referred to as UWP and you would create universal Windows platform applications. And now today for Windows 11, we have WinUI 3, which is, at least in my universe, we now just call this WinUI to differentiate the different versions and what you're building. Because in the component world, where I come from, we have to develop completely different components for every one of these because they're not super backward compatible. But all of these apps were intended to be installed from the Microsoft Store. And you can also sideload them if you really need to do some custom installation. But the main reasons why you would choose WinUI over WPF or WinForms would be if you want that lighter app that's very touch-friendly and published through the Microsoft Store. It's also like a newer technology. So if you want to you want to make sure that your app is newer and cutting edge, you want it to feel modern right out of the box. It's not too complex. And if you're okay only targeting Windows 10 and Windows 11. So for example, let's say you were Meta Facebook and you were developing a native Windows app, for Facebook, similar to Android or iOS. If you were working with .NET, you would choose WinUI, probably not WPF. So WPF and WinForms are primarily for those larger enterprise, powerful applications. For example, if you were Adobe and you're developing Photoshop using .NET, you would probably use WPF. WPF can support touch, but for the battle's sake, we'll give first-class touch support to WinUI. So some other benefits of WPF over WinUI, of course, WPF has been around a lot longer. It's industry proven for over 15 years. As you can tell from the previous slide, the world of WinUI can be a bit confusing, and its future is less stable. WPF has a more rich and stable ecosystem. This means the information and tooling out there is very mature, so mature that Microsoft doesn't even need to add much to WPF. In fact, they announced with .NET 9 that they're adding some new Fluent themes to WPF. It's the first thing we're going to see in WPF in a while. And it's not because WPF is dead, it's just because WPF is stable. WPF is also written in C# for C#, whereas a lot of the WinUI stuff is actually written in C++. Now, this is one of the benefits that Microsoft pointed out at Build, so I take it to be meaningful for certain users and scenarios. And WPF allows you to basically modernize your existing investment if you're coming from WinForms. And a WPF app can also more solidly support past and future versions of Windows. So I mentioned some of those. I briefly mentioned some types of applications that you might want to build with each, but let's look at a few more. Naturally, many of our most used applications today are moving to the web. So of course, we're talking in this narrow universe of desktop native Windows applications. So for example, WinForms and WPF apps, some of these real-world apps might include your internal enterprise applications for business operations. This is your standard productivity application for all of your in-house affairs, especially ones that can't go online. Also, scientific and medical applications for programming devices like hospitals and research centers. They sometimes need to program implants and other robotic devices. They'll run medical tests with some touchscreen capabilities. That can all be done with WinForms or WPF. Very heavy and powerful drafting, imaging, and video editing software, something like AutoCAD or Adobe types of applications would be these platforms. Also powerful editors. So like Visual Studio itself is actually written, or at least part of it's written in WPF. And I imagine a lot of other source code clients out there, like the GitHub and SourceTree, they would use a desktop app rather than a browser. Just for all. WinUI tends to be lighter apps, like a Notes app. Anything that you could run on your phone, but you also want to run on your desktop, like a social media app or a chat app. Anything that's very touch, forward, like app controllers for like your home sound speaker or lights, something like that. If there was an app, it would be written in WinUI. Something that also think about people that use tablets. So people like someone on a warehouse floor running around with a tablet, tracking inventory or some other productivity tool. Those you could write in WinUI just for the light app touchscreen capabilities. And those are just some examples. If you find yourself between WinUI and WPF and it's still not clear, I would choose WPF, and only because of its stability and flexibility. Even if you like that clean, touch-focused look of a WinUI app, you can still achieve it in WPF. And as we know, WPF is here to stay for the long term, whereas WinUI may come with some major changes with Windows 12, or could be replaced with a new framework that's not backward compatible again. We don't know. It's yet to be seen. Hopefully, it's just WinUI 4, and we can just easily migrate, but we don't know. So next, what I'd like to do is we are going to move on to a demo tutorial of using WPF inside Visual Studio. So as I mentioned, Visual Studio is the main tool that you use to develop WPF applications. So you can get actually a free version of Visual Studio. That's actually what I'm using, the community version. And what you're going to do is once you launch Visual Studio, you can go to Create a New Project. And naturally, since you're building a WPF application, you're probably going to want to type WPF. This will help filter out the different project templates that are available to you. Now, you'll notice that several different things pop up. A lot of these things are actually like project templates that are used for certain inner components of your application, like the WPF class library, custom control library, user control. These are things that you'd be using as like an advanced user later on. But to get started, you need to first create the application project, which is either going to be this WPF application or WPF app. Now, there's some distinguishing characteristics here. The one that's called WPF app and in parentheses .NET Framework, that's the legacy project template for .NET Framework. So as you may know, It was referred to as the .NET framework for versions 1 through 4. And then starting with 5, they now just call it .NET, or sometimes .NET Core. So the standard clean application template here that's just called WPF application, this is for .NET 5 and higher. So I will just name my application something like WPF app. You can put it anywhere on your computer. Now on the next screen, I'll get to choose the version of .NET that I want to target. If you're building a new application, there's no reason why you shouldn't target the latest version, unless you have some very specific requirement. So at the time of this is .NET 8. And as you may be aware, Microsoft has announced that like every even version of .NET going forward has long-term support. That means 3 years. The odd versions of .NET, such as 5 and 7, have just 1 year support. They're kind of meant as like an intermediate version. So as we wait for this to load here, so in the center here, and it's currently loading, or the designer rather. Over on the right, typically on the right, you'll see you have in your project. By default, we have a main window.xaml file. We also have an app.xaml file. And if we expand these nodes here, there's also going to be like a C# code file that sort of acts as your code behind for that XAML file. Down here, we actually have the XAML that we can edit. And in the center here, we have the design view. This is sort of the preview of what the UI is going to look like. Now down here in our XAML, you'll notice that currently we have a window element. We'll make this a little bigger. We have a window element, and then inside is a grid element. And this window element has a lot of different gibberish set on it. These are our namespaces for that file. Essentially, these are all like a lot of default things that Microsoft and .NET give you to get started for all of the random basic UI components and things like that. If you were adding a third-party library, you typically would add a namespace here, or sometimes it gets automatically added for you. We also have some fun properties we can set here, like the title of the application. So I'll just call this my WPF application, and this is what appears on like the title bar at the top. We could also change the default width or height if we want. Now over on the left, we have the toolbox. These are all the various UI components that we can drag and drop onto the designer. So typically you'll start off, you'll have the common WPF controls and all WPF controls. So there's various things in here like your buttons, your checkboxes, all the basic components that you need to build out the user interface. Now you can, if you want, you can start by just dragging and dropping some components to the view and start to build your application. And one thing you'll notice is if so for example here I dragged the calendar control over here. If I go down into the XAML and I inspect this calendar control, not only does it give it a name, but it also sets a lot of these alignment margin properties. And that's basically how WPF is positioning this control on the window, on the page, is by these properties. Like if you look at this margin, it has like a 120, 137, 00. It's telling it, okay, position this calendar 137 pixels down from the top, 120 in from the left. Now this is traditionally how like WinForms, would develop your UI. You'd position the control, give it its exact coordinates. Now you can do this in WPF, but it's not recommended. It's not a best practice. What you want to do is you want to sort of build your application using a bunch of basic layout controls first, and then that defines the layout of the window, and then you place all the controls inside with very minimum explicit sizing. So those basic layout controls include the grid, which is similar to like an HTML table. We also have the stack panel, which is like stacks the components in horizontal or vertical list. And there's some other ones in here too, like a wrap panel if you want the items to wrap around, expanders, dock panels if you want to do the traditional like anchoring on the sides of the application like WinForms. But since we just have a grid here, let's get started working with this grid. So to work with the grid, it's like a table. We need to define a bunch of columns and rows. So we do that by just typing directly into the XAML. And I'm going to type in the grid.column definitions tag and open that up. And now I can jump in here and define some columns. So I'm going to go ahead and define 2 columns. And you'll notice up here in the view that our 2 columns are now defined, and they both have an equal width, equally taking up whatever the available space would be. And that value is sort of represented by the value 1 asterisk. So if I were to type in here, the width of the column equals 1 asterisk, that basically means it's going to be 1 times of the available space for this column. If I want one of my columns to be twice the width of the other, I can hit 2 asterisk. Another value that you can give to the width of a column is the word auto, A-U-T-O. And what this will do is this will have that column be automatically the width of its children. So that's what I'm going to want to do here for my first column, is I'm going to add in that calendar control again. And we're going to have it be in this first column. And we want that column to fill that space. So here's what I did. I dragged and dropped that calendar back from the toolbox. Some people like to do that. I didn't have to do that. I could have just typed it right into the XAML. But by dragging it, of course, now I get all of those margins and alignments again. I could come down here into the XAML and remove it. Another little tip that I like to do is if you right-click the control on the designer and you go to Layout, and then you click Reset All, it resets all that layout and gives you that clean appearance for that component. Now let's go ahead and add another control here to the page. I'm going to add the data grid control, and we're going to add this to the second column. Now, if you noticed, even though I dragged and dropped it into the second column, it didn't go there. I feel like sometimes it works, sometimes it doesn't work. By default, everything is going to be in that first row and that first column. If you want to move things around within the grid, you actually have to set I think it's called like an attached property on the component. So every component, you can set these attached grid properties. So if you go in between your data grid tag in the XAML, you type grid dot column, we can now tell it which column to go into. And rows and columns are 0-based index. So that first one by default is 0, which is the same as not setting it at all. If I want to move it to the second column, I'm going to set it to column 1. And I think that data grid actually did not give us any weird layout. So some components will automatically expand to fill the space. Some of them are smaller and will be automatically positioned. So there we go. We have this application. Now, in addition to columns, we also have rows in our grid. So let's go ahead and create some rows. So similar to column definitions, we open up row definitions, and let's define a couple rows here. So now we have 2 rows of equal height. What I'm going to do is actually add like a big title at the top. So what I want to do is I want to move these controls that I already have down to that second row. So by default, of course, they're all in the 0th row. So let's move them all down to the second row by setting grid.row equals 1 on each of these components. And you'd have to do this for every component in your application. But you'll probably notice that, if you're creating a more complex user interface, these components down here would probably be put into another layout control, like another grid. And then you'd only have to set that on the parent grid. But what I want to do here for this title is for this first row is I'm going to add in a text block. And I'm just going to type this one in. Text block is basically like the label component in WPF. And we'll set the text to my WPF application. Now, you notice I've been typing some of these properties, like the text property, these extended attached properties in the XAML. If you have an item selected, you can also go over to the properties window and set the properties over there if you prefer. I tend to, there's so many properties, it actually takes me longer to find it over there than it does just to type it with the IntelliSense over here, especially if you know kind of like the basic name of what you're looking for, you'll get all of the IntelliSense that pops up. Anyway, so as you can see, this the text is kind of small. So what I'm going to do is I'm going to change the size to be a little bit bigger. So I think I will go over here to the property editor to change the font size. So if I opened up the little text category over here in the property grid, I can see all the text related properties like the font family, the size, some of these other attributes. We're going to change the size to be something bigger. How about 36? Now you'll notice now my first column that has my calendar now got bigger, and that's because the text block is within that first column. You might be thinking, okay, this is going to become a headache of trying to get this layout to be exactly as I want. One of the other features to be aware of is the column spanning feature. So on my text block, what I want to do is I want to set the grid.column span to 2. That will allow this element to span 2 columns. Maybe if I had 3 or 4, I'd want it to span that many. That way it kind of goes across the whole top without needing to be separated by those columns, which are really applying to that second row. Now, what you might do is actually start off this application with 2 grids, one at the top, one at the bottom. That way the columns don't even interfere with that top grid. Or you could have a stack panel up there. But this is just showing some, one way to do it. Now, also, I want the height of that to be a bit smaller. So what I'm going to do is on my first row definition, I'm going to set the height to auto, and that will automatically collapse it to roughly the size of that text. And the height of the second row is just asterisk. It's the same as not setting it at all. It's just going to fill the available space. And one last little tip here before I run and build this. You'll notice that my components are all close together. So one of the features you can take advantage of is the margins and padding properties. So the grid component has a margin property. So what I can do up here is just set the margin to some value like 10. And what that's going to do is it's going to add like a 10 margin padding around the entire grid. And if you've ever come across this property being set, like for example, when I dragged that calendar over, it had the margin set with 4 values. The margin and padding properties support 1, 2, or 4 values. If it's set to 1 value, that means 10 is going to be applied on all 4 sides. Or that value will be applied on all 4 sides. If I give it 2 values, like let's say 10 and 30, what this means now is that 10 will be applied on the left and the right, 30 will be applied on the top and the bottom. And if I give it 4 values, such as 10, 30, 20, 10, it'll apply 1 to each as you go around clockwise. But for this, I'm just going to actually keep it at set to 10, just to give myself a little bit of padding. And I could do the same thing if I want padding between the calendar and the grid, my text block. I can go around, add some padding and some margins to sort of space out the application and make it look nicer. And you'll notice that data grid already has some data in it. You might be wondering, where did that come from? So as you notice, sometimes when you drag the controls over to the designer surface, there'll be like some design or some dummy data in there. And oftentimes it's marked separately, so it's not going to be there as part of the final application. It's just that you can help visualize it. When I run this, the data grid will be empty because I've not given it a data source. So it's interesting to point about this running application here. This little tab thing at the top here, these gives you some, I think, like some debugging tools we're not going to need. As I resize my application, you'll notice that the first column and that first row remain a static size, and only essentially that second column and that second row are what are expanding as I resize my application. So this is what we mean by, an adaptive or responsive application. And with WPF, you can create really, with the way that those columns and the grid work, you can create really complex rules for resizing, and not something just so simple as this. Now, there's another basic layout control I want to show, and that is the stack panel. So for this, what I'm going to do is I'm going to actually add a few more components into that first column, and we're going to have them all in a stack panel. And so in order to keep them from overlapping with each other, it'd be good to put the calendar and then any other components I want over there all within another control. It could be another grid with a bunch of rows, but let's do a vertical oriented stack panel. So I'm going to just define this right here in XAML. I'm just going to cut and paste the calendar right up into there. Now, one thing you'll notice is that I'm going to need to take any of my grid attached properties here and move them to the parent. Now, the parent can be the owner of that basic layout. And now within my calendar, I'm going to go and add several buttons. And you'll notice you can barely even see them up here in the stack panel. They're very small. That's because they don't have any content yet. And when you go to set the button, the first thing you're probably going to want to do is set the text. And you start to type text, you start looking for the text property, you can't find it anywhere. There's this text block. That's not really going to let us set the text for this. If you're coming from WinForms, you might say, oh, maybe it's value. No, there's no value property. Well, how do I set the text of the button? This is another big concept of WPF, and that is the content concept. They use the word content to mean anything that is between the tags of an element. So anything that's put in between the tags of my button is the content. And I guess for the button, they decided that the contents of the button are going to be called the content. They're not going to give it like some text property. And the real flexibility of this is that now our button can have anything we want in it. I could put a stack panel inside my button. That stack panel can have an image, some text, another button. So you're really free to do anything you want with this content. A lot of times the content can only be one element, but then if you want to have multiple elements, you just have to put them all into like a parent container. So here, you could also, this is also, I think, just like a helpful feature. They allow you to just type the text raw right into the XAML. I don't like to do that. I like to actually be official. So if I'm going to put just text in my button, I'll add an actual text block. And that also now gives me a lot more properties and features. So if I want to change the attributes of this text, like make it bold, change the size, I can now more easily do that on the text block object rather than if it was just written in there. Now let me just go ahead and, for these ones, I will just cheat just to get some, quick text up here. Now, another thing you're going to probably try to do as you're designing your application is you're going to start to change the colors and the styles. So a lot of components have properties. If you look over here in the property grid, they have style-related properties. Oftentimes, if you find the brush category, this will show you all of the different style elements that you can change for this. So the button has a background, it has a border brush, a foreground, which is essentially the text color, and we can change all these over here. And one of the benefits of WPF over WinForms is the ability to create these style objects. And style objects allow you to define a style and reuse it across your application. Like let's say our application, we want to define a button style that's green. We could just set the background of this button to green. And of course, here I'm just going to use like simple, common colors, but you can actually come over here and you can get the exact RGB, the exact hex code that you need. We could set this button background to green, but let's say I have a huge application with 100 buttons. I don't want to have to necessarily go through, change them all to green, and then have the review team come back and say, oh, actually, the color of green you're using is off. So what we want to do is create a reusable button style. And we can do that in a variety of different ways. Styles are typically defined within your resources collection. Resources can exist on the window level or on the page level, or they can exist on the application level. If I want to create a style that's only for this window, I could open up my window.resources tag, and I can define a style right in here. And this style will work only on this window. If I want to create a style that works across the entire application, I'm going to go to the app.xaml file. And this is where you can define reusable resources for the entire application. So let's go ahead and actually define our style in this section for this demo. So you create a style by opening up a style tag, and the first thing you want to do is you have to set its target type. And this is going to be the type of element that you're targeting. So here we're targeting a button. And then within the style, you're going to create a whole bunch of different setters. And these setters, for each setter, you're basically setting a property. So here we're going to set the background property of the button. And then we're going to set its value to green. And now when I jump back over to my window, you'll see that all of my buttons are green. And I can actually come back down here now and I can remove this color here. But now let's say there's one button on my application that needs to be red. I can actually still override that style by using an explicit inline style setting. But now let's say we have a bunch of buttons need to be green, a bunch of buttons need to be red. We need to create multiple styles. We can come over here to my app.xaml file, and I can simply just copy and paste this and create a second style. Now the problem is, how does the application, it's probably giving me an error now because it says I already have a style defined for buttons. How do you define multiple styles? You have to give it a key. And essentially now we are creating an explicit style, and we have to give it a name. So like this will be called my green button style. And this one we'll call my red button style. Now, once you're in the world of creating these explicit styles, now there is a little bit more work because now every instance of the button throughout my application, I have to specify which style that we're using. And we do that by simply setting the style property. And we use the curly braces and this key term here, static resource, and then you give it the name of the button style. And it even pulls automatically from the available styles. So for this first button, we'll make it the green button style. Second button, we'll do green as well, and we'll make the third one red. And there we have it. We have different styles being used. And we can also do more things in the style rather than just colors. The setters can be any property you want. So let's say we actually want to add some padding. Remember I showed the margin to sort of space it out? I don't like how the buttons are all touching. So we can actually set that on the button if we want to give the button a little bit of space around it. So we'll set the margin property up here. So I added the margin here into my style. So now when I come back here, my buttons, at least the green buttons, are spaced out a bit more. And probably one of the most obvious things you're probably thinking is, okay, if I have a button, then I need to be putting some code in there. How do I do that? If you're used to WinForms or anything else in any other .NET framework, you're probably used to events, event handlers. So in addition to the properties, in the property grid here, there's a little lightning bolt. And if I click that, that shows me all of the events for the controls. So if I click the events for this button, I can see all of these different events, things like, relating to, touching, the mouse moving and dragging, enter, left button, click up, all these things. Most common scenarios for a button, you're just looking at the click event. So if I just double click the click event, it'll automatically generate me an event handler. And this now jumps me over to the C# file that's behind my XAML view. And in here is where I can start to put my business logic. Now, this is where we get into talking about one of the other major concepts of WPF, and that is data binding. Because in a well-developed application, we try not to write too much business logic in our code behind. We want a lot of that to be separated into a model. So that takes me on to my next topic, which I'm going to jump back over to my slides. And that is data binding. So data binding is a key principle of WPF. As I mentioned, you can data bind anything to anything in WPF. And so, yeah, you could actually bind like the background of that button control to, let's say, like a color picker component that you have on the window. That's very fun and cool, but it's not actually the core use case of the data binding features of WPF. We're more interested in how we're going to bind all of our UI components to our data model. And Microsoft designed WPF and other XAML-based frameworks, including WinUI, so you can easily separate the UI from your business logic. So if you think of it like this data model here, the UI is our XAML. Every part of the UI that can change or behave differently based on the data is data bound to properties, C# properties on the data model. Now, this data model includes all of our business logic. So the properties, they represent our values, our objects, and even the commands. Now, the commands are typically the actions that you take upon those values and objects. So the model also gets the data from the data source. It performs changes and updates to that data. It also notifies the UI when the changes are made. And it includes the logic for button clicks and things. These things are known as commands. So WPF and WinUI both have this feature more baked into them than, say, compared to WinForms. And maintaining a clean separation between application logic and UI, it helps address many different development issues. It makes an application easier to test, maintain, and scale. And this model is widely known as MVVM, which stands for Model View View Model. The MVVM pattern helps cleanly separate an application's business and presentation logic from its user interface. And once you start developing with WPF, you probably won't escape the discussion surrounding MVVM, as it's widely regarded as one of the best practices. And with MVVM, the view model is essentially the data model from my previous diagram. It includes all of your business logic directly related to the view. The model here is really just the data schema that defines each business object. It can also have your data validation, sometimes, connections to your data source. But those data sources remain an external part of the model and view model that those things still have to connect to, whether it's SQL Server, an Azure data service, whatever. And this data binding syntax here on the left, this is what it would look like for any property on my view. Just a simple curly brace, and we name the property from our view model along with the word binding. So this is similar syntax to how I connected that style using the static resource a bit earlier. And the view model is going to then expose all of the application variables and all the objects and the values that are going to be changed. So for example, here, my list. And then the model is just the collection of these objects and classes like my object. And all the business logic typically lives within the view model. And it's a good practice typically to have one view model for every view. So next, let me show you a basic introduction to MVVM in our sample here. Now, there are a lot of different libraries out there that can help you. There's a lot of information out there. So keep in mind that MVVM is really just a guideline for your application architecture. It's nothing more. It's not one specific library. It's not one specific technique. You can even just sort of do some MVVM style and then still have some, tightly bound code to your UI. It's still fine. Just think of it as a guideline. So really, because of that, you don't need to use any third-party library. And in fact, I would suggest not using one until you understand that way, because once you start diving into, these libraries, I feel like it's confusing if you don't understand what's really happening behind the scenes. So let's jump back to my application here. And what I'm going to do is, since I don't have time to show how I'm going to connect to a data source, I'm going to add an existing project to my solution here. So I created a project earlier that just is going to connect to the data source and give me my view model and everything. So that'll save me some time here. So here I have a demo data source that it's using an OData service from the Northwind database. So in here, I've also defined my product model. I can open that up and show that to you. So this is essentially the model aspect of view of MVVM, is just defining all my objects. So here I just have one object called product. Next, I'm going to add in a view model class. I'm going to add this into my main WPF application. I'll go ahead and open this up. So my main view model here, it basically is now going to expose the properties that I want to bind to in my view. So we have here a property of products, It's a list, and then, and it also has the logic here for loading the data asynchronously. I also need to go ahead and just connect this to my reference I just added. Bear with me here. So I have to do this because my model is defined in that separate project that I added there. Okay, so now we have here on the main view model here. So one of the keys to following MVVM is that your view model class has to inherit from this interface called iNotifyPropertyChanged. This interface includes one event that's called upon when any property in our view model or model is updated, called the property changed event. So this basically tells the WPF UI to listen for updates to that property. And why this is so important is because so much of our data processing today is asynchronous. So we don't want that application UI thread to hang while the data is loading. So here I'm just using some crude asynchronous .NET code here to load the data from my data source. And when it's completed, I call notify property change, and I pass in the name of that product, or that property, which is called products. And this will tell the UI that the products are updated, and hey, tell my UI to update. And so what we're going to do now is we're going to basically connect this view model to my view. That's the next important step. Now, there are many different ways and many different approved ways to do this, I think. I think the smartest way that you might find out there is what people will describe as a way to basically create a data template, take advantage of the data template feature of WPF to connect all of your views to your view models. I think it's a bit more complex to start off with, so I'm going to show you the most straightforward and basic way to connect a view to a view model, at least in my opinion, and that is using the data context property on our elements. I think every UI element, I could be wrong, has this property called data context, which is essentially the data source, for that property. So one thing I can do here is on my window, I can set the data context for the window of my view to an instance of my view model. And that is essentially going to create a data source for that view. So let's see here. I'm going to set window.dataContext. Now in here, let me get rid of this resources. I don't need that. Now in here, I need to create an instance of that view model. Now the view model is not a component that I can't drag from the toolbox or anything. However, it is a class in my project that I can access locally. And one of these namespaces that we get in these WPF application templates, the XMLNS local, well, this is the local namespace for my project. So I can access any custom components and classes that I create in here are all accessed under the local tag. So if I type local, now I can find my main view model. And by doing this, I'm essentially creating an instance of it right here. So when this runs, an instance of the view model is created. Therefore, the properties now on that view model now exist. Now my UI elements can be bound to the properties of this view model, and all the notification, all the magic starts happening. Next thing I want to do is I want to bind the data grid to the products collection. So you go down to the data grid, you might type in data source or something like that to try and find the property. The property to connect the data grid is actually called the items source. And you might think that's a little weird. I believe the reason is because in WPF, there's this thing called an items control. And it's a more basic control that's just a collection of items, like a list. And I think data grid extends from that. So it inherits that type of property in that syntax. Anyway, item source, and we're going to set binding inside curly braces, and then we'll see the IntelliSense pops up. And now we're going to get all these various properties and things that we can set in here. But you'll notice the one that has the little blue symbol on it, it's coming in from the data context, products. So I can bind that to products. And I believe that is all I have to do. Let's see if this works. And also just another tip to point out, I set up that binding in XAML. Something to note that anything that you can do in XAML, you can do in code with WPF. I would say one of the best practices and one of the tips you should learn is that try to do everything you can in XAML. It just sort of creates a nice, clean result. And of course, my Visual Studio is a little slower today, probably because I'm live streaming. And there we have it. Now, if you notice briefly for a second, the data grid was empty, and then the data came in because it was being loaded asynchronously, and that's exactly what we want. And you could even enhance the UI to display a little loading text as it's loading and that sort of thing. But that's it. We pretty much have completed that. One last thing I want to quickly show you here. Oh, so that's basically the data binding in a nutshell. There's some other concepts that you should just be aware of. Like I mentioned briefly, commands. Commands are typically used as a way to, sort of create button and action logic in your view model, as opposed to, a property or collection. And in addition to, organizing your code, following MVVM also helps organize all of the files in Visual Studio. I just dumped the files right in here, but if you come across other samples out there, you'll find a lot of developers will organize things. Like they'll put their view models here, they'll put the models here, views here. And basically, one of the best design practices for MVVM and WPF is to try and write as little code in your code behind as possible. Code that is tightly bound to the user interface, is not as scalable or testable. And since it's not organized, it can become difficult to maintain. And before we wrap up, let me show you how you can add additional libraries to your application. So I work for Meshes, and we have many additional WPF controls that expand and fill out your toolbox. And there are some good free libraries out there. So for example, there's this library called the Community Toolkit.mvvm. That's the one I would recommend using if you want to take your MVVM skills to the next level and not have to write things like that iNotify property changed and some of that code that I had. They simplify that so you can, write essentially just little square brackets above your classes, and it automatically handles things like that. And you may have noticed that this WPF data grid is a little odd looking. I think the style out of the box is a little rough, with the gray headers and those bold black lines. Surely you could probably customize that. But let me show you one of the third-party components that we have with ComponentOne, and that is our Flex Grid control. The quickest way to get started with it is open up the NuGet package manager. So because we're working in .NET 8, the preferred way to work with third-party UI controls is through NuGet. So open up my NuGet package manager, and these package sources are going to come from NuGet.org. And here I'm just going to search for the c1.wpf.grid library. I'm going to select this one, which is version 8. Select the application you want to install it into, since I have 2 projects here, but we only want to use this WPF demo app. Then you click install. And even if you've never installed anything from our website, this will still work for you. Especially, it'll start like a 30-day trial if you don't have a license installed. Accept all that. It also brings in any of the dependencies that are being used. All right, now let's go ahead and open up the XAML page. And once I have the NuGet package added, which we can see if we open up the dependencies packages folder over here, we'll see I have the WPF grid package is installed. Now what I can do is I can find the control in my toolbox and drag it over. So specifically, I'm looking for the flex grid. So I'm going to go ahead and drag the flex grid over here. Now, if you installed the ComponentOne WPF edition, you'll notice that we actually do try to put all the components in the toolbox. And really, that's just there for people that are used to developing that way. It's not really the preferred way. You should first add it to the package reference. And so, for example, if I were to drag a control over that I don't have the NuGet package reference for example, C1 calendar, if I drag that over, I'm going to get a pop-up that says I don't have that package added. I need to add c1.wpf.calendar. So if I go add that package, then I can come back and add it. And sometimes, depending on, it really depends on, if you're doing WinForms, WPF, WinUI, whatever, and also the version of .NET. Sometimes the NuGet package controls do appear in their own little group. For some reason, they're not appearing for me today. So one thing I'm going to do here is I'm going to right-click this flex grid and reset the layout. Sorry, Visual Studio is being a little slow. Let's just do it right down here. We'll just do it down here because it's going a little slow for me at the moment. I'm going to remove all of this. And I'm going to have this flex grid essentially replace everything that the data grid has. We're going to get its item source, and we're going to take its grid.row1. And I'm going to need this column.1. And we'll just get rid of the data grid. And we'll run the application. And also, if you have any questions, feel free to enter them in, and I'll answer them here before we wrap up. One of the other neat features of WPF and a lot of the XAML platforms is this feature called XAML Hot Reload. So there's this little button up here. So instead of stopping and building the application every time, I could just have it debugging. Maybe if I have two monitors, have it debugging on the other monitor. And then anytime I make updates, all you have to do is click the little flame, the hot reload, and it kind of does like a lighter rebuild, refresh of the application for you. But for this demo, I'm only building it 2 or 3 times, so I didn't get around to doing that. So now you can see here, we have the flex grid here instead of that data grid. The flex grid just looks a lot, sleeker and more stylish, especially right out of the box. And we could, of course, take this a lot further, adding a lot more features to the data grid. We could also replace the calendar with C1 calendar, add some themes, do a lot more there. But that basically wraps up today's presentation. In summary, I believe WPF is still the best UI platform for new desktop Windows development. Compared to WinForms and WinUI, it offers XAML markup, which is ideal for creating adaptive and responsive interfaces for any size screen, flexible styles and data binding concepts. These are the core of what WPF can do better than WinForms. Those features naturally make WPF more MVVM friendly. Or more simply put, WPF makes it easiest to separate your business logic from the UI. And this is ideal for code maintenance and testing. And since WPF talks directly to the video card, it gives you the best performance. It's now very industry proven now for 15 plus years. The ecosystem is vibrant, including WPF ComponentOne UI controls. So for those reasons, WPF remains the ideal choice for modern native Windows desktop applications. And that's why you should choose WPF for your next WPF application. The library I mentioned briefly, if you do want to take your MVVM skills to the next level, just use the community toolkit.mvvm. That's probably the closest thing to the most official library out there. It's a good place to start. And if you want to do any advanced UI components, take a look at the ComponentOne WPF controls. Do we have any questions? So do the C1 WPF controls work in .NET 4? So yes, so we have we currently support .NET Framework 4.62. Support for 4.52, I believe that support's going to be coming to an end soon here, but 4.62 and higher, so 4.62, 4.7, 4.8, we do. For the old 4.0 stuff, those controls are no longer supported, but you can still download the latest version from our forums. All right, and as I mentioned before, the ComponentOne UI controls for WPF, over 100 custom WPF controls you can download from developer.meshes.com/componentone/WPF. These controls expand that standard toolbox with additional controls like charts and reports, and as well as advanced features for the classic controls like the data grid, like I showed with the flex grid, and input and layout controls as well. And as you saw, you can also quickly get started by just downloading the NuGet package, adding it to the window, and you're off and running. That wraps up this Code Clinic. So thank you all for watching. And we'll catch you later. Bye.